This lesson is the Moivre theorem part 2. So here we have an example of a complex number, and we want to do this in fifth power. So complex number 1 plus I to the fifth power. First thing we need to do is write this complex number in polar form first. Okay, polar form first. So our complex number is 1 plus I. Our x is 1 because this is x. Our y is 1, so this is 1. If we graph 1, 1, that will be in first quadrant. Okay, so 1 plus I is in first quadrant. Okay, so next we need to find r. So x squared, y squared, the square root of the whole thing. And then put 1 in, it's just 1. Put 1 in, it's just 1. 1 plus 1 gives me 2, so square root 2. Don't forget, you have to square, okay? Don't forget to square. So 1 squared is 1, 1 squared is 1, 1 plus 1 gives me 2. So that's my r. Next, we need to find our tangent. Tangent is always, angle. We have to find our angle. So angle is always tangent, okay? One more time. To find the angle, it is always tangent. And we know that tangent is yx. So put y in, put x in. Y is 1, x is 1. So 1 over 1 is just 1. Bring the tangent to the right side. Bring the tangent to the right side. So I have inverse. Okay, inverse tangent. So the inverse tangent of 1 is 45 degrees. Okay, just put this in your calculator. Okay, so just to make sure that you see it. So here we go. So why is it 45? So second, and tangent inverse is right here. So that's where the tangent, put the 1 in, close the parentheses, and then press, before you do anything, make sure it is in degree mode right here, degree, okay, make sure it's in degree mode, okay, and then press equal, and there it is, 45 degrees, okay, so 45 degrees, okay, all right, and since the complex number is in first quadrant, then we don't need to do anything else. It stays as 45 degrees. One more time. Our angle is 45 degrees. However, our complex number is in first quadrant, so it stays as 45 degrees. Because it's in first quadrant, it stays as 45 degrees. We don't need to subtract anything else because it's already in first quadrant. So it stays as 45 degrees. Now rewrite, now use the r, use the angle. Now rewrite the complex number in polar form. Okay, polar form. This is complex, this is polar form. So polar form, r is always outside. Again, r is always outside. Followed by cos 45 plus I, and then sine 45. Okay, so make sure you write polar form like this. R outside, followed by cos plus I sine, and then put the degree in. Okay, so this is complex number, this is polar form. It is the same location on the graph. Okay, it's just written differently. Okay, however, this is only in first power. This is first power. What we want to know is fifth power. Okay, what we have here where I am circling, this is first power. We want this in fifth power. So what do? Make this into fifth power. Okay, so what we have here, but we want it in fifth power. So here's my complex number to the fifth power. Take this whole polar form to the fifth power right here. Take this whole polar form right here, make it into fifth power. Okay, so now distribute this fifth power to every single one of them. So fifth power to square root 2. Fifth power, instead of power this to the fifth, you take this 5, multiply by the degrees. Same thing with the sign. Multiply with the degrees. So one more time. To do the fifth power, 5 to the fifth power with the square root 2. 5, multiply the degrees right here. Multiply the degrees. 5, multiply with the degrees where I am pointing at. Okay. So Square root to the 5th power, write it out. There's 5 of them. Why 5? Because this is 5. 1, 2, 3, 4, 5. Okay. However, we can simplify this. 2 times 2 times 2 times 2, that gives me 16. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Well, this square root 2 is left over. Okay, this is extra. This square root 2 right here where I am circling, it is extra. So leave that one alone. Okay, so 5 times 45 is 225. 5 times 4 is also 225. Well, what is square root 16? 4. What is square root 2? Leave it alone. Okay, we don't want decimal. Leave it as is. Use your chart. Make sure you use the table chart, the trigonometric table chart that was given to you in past lesson and PowerPoint. Look up cos 225. Again, I don't want decimal. I want it in exact value. This is the value that I want. Do not give me decimal. Same thing with sine 225. Okay. Now all you have to do is just multiply across. Multiply, distribute 4 square root 2 times negative 1 square root 2. As you can see, the square root 2 can cancel out. All I have is just negative 4. Same thing with this one. 4 square root 2 times negative 1 square root 2. The square root 2 gets canceled. So I just have negative 4i. So here's the 4i. Don't forget the i. So 1 plus I to the 5th power is negative 4 minus 4i. Okay, so this is what we're looking for. This is the answer we're looking for. Okay, now what is that in the graph? So this right here, again, this graph, what I have here, I just brought it down here. So our original complex number in 1st power was only right here, just right here. But we made this into 5th power. So 5th power is down here. Okay, so 1st power, this was the original 1st power. We made this into 5th power, so it's over here. Okay, again, what I have here is not accurate. It's just approximation. Okay, so 1st power, 5th power, which is on this side. Okay, so that is when you do to the 5th power. Okay, now we're going to do the same thing. Okay, but this time we're going to cube root this. Okay, we're going to cube root. So here's an example of complex number, negative 1 plus square root 3i. Okay, so here's our complex number. X is negative 1, y is square root 3. Let's plot negative 1 and square root 3 on the graph. So it's on the 2nd quadrant. Okay, negative 1 square root 3, 2nd quadrant. Okay, all right, so same thing. Let's find r. So negative 1 square root negative 1 square is just positive 1 square root 3 square. The square root and the square cancel, so I have 3. 1 plus 3 gives me 4. Square root 4 gives me 2. Okay, to find the angle, use tangent. Again, to find the angle, always use tangent. And tangent is y over x, so y is square root 3. Negative 1 is the x. Simplify this, comes out to be negative square root 3. Okay, bring the tangent over to the right hand side. Okay, and then you will have tangent inverse in parentheses minus square root 3. We use that in your calculator and it came out to be negative 60 degree. Okay, negative 60 degree. However, we are in 2nd quadrant. We are in 2nd quadrant, so therefore 180 subtract 60, which will give me 120 degrees. Okay, so this is the angle that we need. Okay, so one more time, your calculator will come out to be negative 60. However, we are in 2nd quadrant. Because we are in 2nd quadrant, we have to take 180 subtract 60. Okay, so that gives me 120 degree. This is the degree that we need. Why? Because it is in 2nd quadrant. Okay, so now rewrite this complex number into polar form. Again, r is always outside, followed by cos 120, I sine 120. Where did the 120 come from? 180 subtract 60, which is 120. And this is the degree that we need. Why? Because we are in 2nd quadrant. That's where the 120 comes from. Okay, so this right here is to the first power in complex number. This right here is also the same thing, but in polar form. Both of these are the same thing. Complex number in rectangular form, polar form, same location on the graph, just different writing. But that's what we don't, this is not what we want. What we want is the cube root. So we're going to cube root this, okay? We're going to cube root, okay? We need the cube root. So we're going to cube root this 2. That's where the cube root comes from. Cube root this 2, okay? Cube root this 2. That's where the cube root comes from. And then since we're cube root the whole thing, we're going to divide 120 by 3. Okay, that's where the 3 come from. Cube root plus 360k over 3. Why 360? Because it is one time around the circle. What is k? How many time around the circle? Where's the 3 came from? Cube root. One more time. We want cube root. So cube root r first. This is r. This is r right here. We want to cube root r. Okay. And since we're cube root r, we divide 120 into 3. Where the 3 come from? Because it's cube root. Why do we have to add 360? Because it is one time around the circle. Okay. One time around the circle is 360. What is k? K means you're going to do it many times around the circle. As many times around the circle as needed. Okay. And again, where did the 3 come from? Cube root. Okay. And you will do the same thing with on this side with sine. Do the same thing with sine. Since we're cube root, divide 120 with 3. That's where the 3 come from because it's cube root. 360 because around the circle is 360 degrees. Where the k come from? K means how many times you're going to go around the circle as needed. And then the 3 divide by 3 because it's cube root. Okay. So whatever you do to cos, you do the same thing with sine. Okay. So again, cube root, you cube root the 2, which is the r. Divide 120 by 3. 360 because around the circle is 360. K, how many times you will go around the circle as needed. And then cube root, divide by 3. Do the same thing with sine. Okay. So let's simplify this part right here. Cube root 2 is just cube root 2. We leave them alone. 120 divided by 3, that gives me 40. 360 divided by 3 gives me 120k. Same thing on this side. 40 plus 120k. Okay. However, again, k is how many times you go around the circle. So how many times? 3 times. Why 3? Because it's a cube. Okay. K means how many times you're going to go around the circle. K means that how many times around the circle. So how many times? 3 times. Why 3? Because it's a cube. That's why. If this says 4th, you go 4 times. If this is 5, we go 5 times. Here it says cube, so we do 3 times. So k always start with 0, 1, 2. Do not start with 1, 2, 3. K always start with 0 and then 1, 2. That gives me 3. Okay, that's where the cube come from. 3, 1, 2, 3. Okay, again, k always start with 0, not 1. So 0, 1, 2. Cube, there are 3 of them. Here's 1, here's 2, and here's 3. So plug this in, starting with 0. So if you put 0 in, okay, start with 0. Put 0 in for k. 0 times 120 is just 0, so I just have 40. Same thing here. Put 0 in, I just have 0. 40 plus 0 is just 40. Okay, so first one is 0. So put 0 in. This disappeared, so I just have 40. So sine 40 as well too. Next, you put k in for 1. Okay, put k in for 1. 1 times 120 is 120. 120 plus 40 gives me 160. Same thing with sine. Okay, put k in as 1. Put 1 in. 120 times 1 is 120. 120 plus 40, 160. Okay, and then put 2 in. 2 times 120 is 240. 240 plus 40 is 280. Okay, so one more time. Put K in for 2. So put 2 in right here, 2. So 2 times 120 is 240. 240 plus 40 gives me 280. Same thing with sine. Okay, now where are these three on the graph? Where are these three on the graph? So here's the graph. So here's K when is 0, K is when is 1, K is when is 2. Again, what I have here is just approximation. Just approximation, okay? It is not exact, okay? So again, what is K stands for? K stands for how many times you will have it around the circle, okay? That's what K stands for, okay? And why 3? Because here it says cube. So this is the answer that we need. Okay, 3 of them around the circle. K0, which is right here. So that's the first spot. This right here, when K is 1, which is here. This right here, K is 2, which is right here, where I'm moving my pen. Okay, so this is where the answer is R. Okay, around the circle, 360 degrees in 3 places. Okay. Again, what I have here is just approximation. It is not an accurate spot, okay? All right, just approximation. So this example is to find the cube root. The cube, when you see root, when you see the root, it could be 4th root, 5th root, 6th root. The root means how many times in this circle, how many time around 360. Okay, if it's 3, make sure you must have 3. If it's 4, you should have 4 around the circle. Okay, so that's what cube root is. Okay, now back to this example, to the 5th power. 5th power means you're making this complex number to the 5th power. Okay, so the original was here. This is the 1st power. 5th power is right here. Okay, so this is the second part of the Moore's theorem, using to the power and to the root. Okay, so be very careful in this second part of the lesson.